Hi everyone and welcome. In today's lesson we're going to continue to look at our parabola, or what is also known as our quadratic function. Now, before we look at our new form, I just want to remind you what we learned about in the previous lesson. So we had our function which was fx equals to ax squared plus q, where ax squared was our x squared term and q was our constant term. When it looked like this, we only had an up or down movement of our parabola. But now, in our next type of parabola, it's going to look like this. We have fx equals ax squared, where this ax squared is our x squared term, but we also have a plus bx term, which is a x to the power of 1. So this is the x to the power of 1 term that I referred to in the previous lesson. And then we have plus c. Now, just to quickly show you, when we have this x to the power of 1 term, it means that our parabola also moved left or right. So, another thing that you need to remember is that this c is not the same as q. Because in this example there was no left or right movement, only an up or down movement, our q was also our turning point. But this c refers to our y-intercept. Now in this example, our y-intercept will be over here, but we also know, because we have an x to the power of 1 term, our parabola might have moved left or right. Now this is only an example, so we know that our turning point will not be on our y-axis. Okay, so that's very important. So in today's lesson we are going to learn how to calculate this turning point when we have a parabola in this form, and you also now know that this c is this y-intercept. So keep these things in mind because we're going to use them in the next example. Here we go with the following example. So we are given fx equals x squared minus 6x minus 7, and we want to draw this quadratic function on the Cartesian plane. Now before we start, we really want to get an idea of what it looks like in our minds. So let's just run through this example. So here is our x squared term, which means we have a parabola. Then we also have an x to the power of 1 term, which means that this parabola has moved either left or right. And then we have a c, which is our y-intercept. We also know that this a in front of the x squared, this coefficient, is a positive 1. So that means the legs of the parabola will be pointing up. But this function isn't as easy to draw as our previous lesson's function, because here we have to calculate our turning point first. Now, when a parabola is in this form, we can easily calculate the turning point with the following two formulas that you have to learn by heart. So, look at how I write it in the form of coordinates, because we're actually calculating the coordinates of the turning point. So, to calculate the x-coordinate, we are going to memorize the following formula, which is minus b over 2a. And to calculate the y-coordinate of the turning point, we memorize 4ac minus b squared divided by 4a. Now all that we need to do is we have to do substitution of this b, this a, this a, this c, this b, and this a. So here we go. The turning point is equal to, so we take this minus, we write it down, and in the place of b we're going to put this minus 6. Okay, because remember our function is in the form of ax squared plus bx plus c. So we take this minus 6 and we put it in here. There we go. And then we write the 2, and in the place of a we put this coefficient, which is 1, and there it is. Then we write the 4, in the place of a we put the 1, there it is, and in the place of c we put the minus 7, there we go. We write the minus, and in the place of b we put the minus 6, there it is, and we leave the square on the outside of the brackets, and then we write the 4, and in the place of a we put the 1. So we do this calculation on our calculator as well as this one, and you will see that our x-coordinate will be a 3 and our y-coordinate will be minus 16. So our turning point is at 3 and minus 16. So it's 3 to the right and 16 down from the origin. So 3 to the right and 16 down, and we can plot our turning point right there and write in the coordinates 3 and minus 16. Now that was quite easy, wasn't it? So now we have to put in our y-intercept, and lucky for us that was given to us as -7. So our y-intercept is -7, and I put my dot there on the y-axis, and there is our y-intercept. Now I can put in the coordinates, which is 0 and -7. Now from here we know that our legs will be pointing up, so we know that our parabola will go through our x-axis on this side as well as on that side, so we need to calculate our x-intercepts. Now how do we calculate the x-intercept for a quadratic function? Well, we're going to make the y as 0 because it's the x-intercepts, and then we're going to factorize. So there is our 0 equals to x squared minus 6x minus 7, and this is a trinomial, so we can factorize this trinomial. And if you can't factorize a trinomial, we can use the quadratic formula. Okay, so this lesson is also not about the factorization rules. I just point them out so you can go back and look at how to factorize a trinomial or what the quadratic formula looks like. So once we factorize this, we end up with 0 equals to x minus 7 in brackets and x plus 1 in brackets. This is our zero product rule, so you know how this works. What makes this bracket a 0 when this x is a 7, or what makes this bracket a 0 when this x is a minus 1. These two are our x-intercepts. So x is 7, so that is 7 and 0, that's right there. And x is a minus 1, which is right over here. Now again, I'm not drawing this according to scale, I'm just trying to get it as accurate as possible. And there is all our important points. So now I can connect it with our parabola, and there we go. And we are done. As easy as that. Now, here is another thing that I want to point out for those of you who are familiar with calculus, or maybe you're going to learn calculus a little bit later on. We can also calculate this turning point's x-coordinate by using calculus. So we take this normal function, our original function, and we can get the first derivative. Now the first derivative of this original function is 2x minus 6, and you know from calculus that if we have our first derivative and we equate it to 0, we calculate the x-coordinate of our turning point. So all we need to do is to calculate this x after equating our first derivative to 0. So we take this minus 6 to this side, becomes plus 6, and plus 6 divided by 2 is 3, and our x-coordinate of our turning point is 3, and there it is. Now some of you might wonder, where do we get this y-coordinate from then? Well, if we have the x-coordinate of our turning point, well, we can basically just take this x-coordinate, substitute it into the x in our original function, and then we will get the y-coordinate. So we put 3 in there as well as in there, and if we calculate our y, you will see that we get minus 16. As easy as that. Okay, so just before we finish off, one last thing. What will this parabola symmetry line look like? Okay, so again, I'm going to draw it in. The symmetry line is always where the turning point is, and it's a vertical line. And the coordinate of this turning point, the x-coordinate, is a 3. So this symmetry line, this vertical line, will go through our x-axis at 3. So that means our vertical line, or the line of symmetry's equation, will be x equal to 3. And there we go. So there's a lot to remember. Work through this video and make sure you remember these formulas and how they work. See you again next time. Bye.